Hello, Mus, I am audible. Just please confirm me whether I am audible or
Yes,
not.
sir. Yes,
Even I
sir.
will
Yes,
see
sir.
chat box also. You are not audible, Manoj.
Sir, audible now? Hello. Hello.
Hello? Okay, okay.
Hello.
Yes, yes, audible, audible.
Hello.
Yes, yes, audible. Screen is
Okay,
visible.
thanks, sir. Yes, sir. Visible.
Question number one, CFD carried out.
Sir.
Okay, okay, fine. So let us wait.
Yes, sir.
Let us wait 2-3 minutes more. Then we'll start.
Sir.
Maybe another
Sir. Sir.
student will join. Okay, one student also join. So let us wait
Thanks.
2 more minutes.
Okay. 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 Okay, sir.
Okay.
Okay.
Okay, let us start. So the first question is, let me just take the pen. Question number one. So CFD carried out the observational experiment, analytical experiment, field experiment, or numerical experiment. Very simple question from your CFD. So this question from basically hydraulic engineering 2024. Same NPTEL hydraulic
So,
engineering.
so
So
CFD means what, sir?
CFD, I think you have covered or not? Week number 11?
Week number 11.
Ha.
Yes, sir. Yes, sir. Cover.
Okay, okay. Computational fluid dynamic, right?
Okay, okay. Okay, sir.
So this is the meaning of CFD. So please, just based on your understanding, whatever you have learned week 11 videos, so you can write in the chat box your answer. Okay, you are telling C. Okay. Actually, here C is not correct. So you can rethink, because here we are talking about computational fluid dynamic. As name suggests, computational, something computer will be involved. So based on that, please try to think. Okay, let me just discuss very in simple way. Basically, CFD is nothing but whatever you have the equations, like the Navier-Stokes equation we have already learned, and Euler equation, or your Laplace equation. Okay, Manoj is telling analytical. Okay, not here analytical. Not analytical means okay, not analytical. Let me just. Okay, many student Amit also joined. So Amit, you can also write your answer, please. For question number first, Amit and Prajapati. CFD carried out the observational, analytical, field, or numerical. Which one? Manoj is telling analytical means B option. So based on your, so you both please write, then I'll discuss. Just please, just write as quickly as possible. You write your answer, then I'll discuss. So CFD means here computational fluid dynamic. Okay, so let me discuss. So actually, what you will do in the CFD, actually you need to solve some equations, whether Navier-Stokes equation, your Euler equation, Laplace equation, Bernoulli's equation also you will solve as per requirement. Also lot of equation, heat equations also. So for solving your equations, that is this partial differential equation, these are the group of partial differential equation, remember please. Partial differential equations, and these partial differential equation converted in algebraic form. Algebraic form, and in CFD we actually solve these algebraic form equation using the your finite element method, finite volume method, and finite difference method. So remember please. So basically the observation means, let us assume you are conducting some experiment. Let us, you are measuring velocity in the pipe using any instrument. So that thing known as the observational. Analytical means you are some physical concept, you are writing some physical concept in terms of mathematics. That is a mathematical solution. But here in CFD you actually what solve? You solve the algebraic equation which is derived by your finite difference method, finite element method, finite volume method, depend on your application. And we use generally in CFD, in case of your fluid mechanics, finite volume method, remember please. So actually the for solving the your let us suppose you want to some, you want to find out the velocity. Let us suppose you have one channel and water is flowing, let us suppose 1 meter width depth, and you want to find out here velocity. So observationally you can find out using the instrument, but numerically or computational, when you will apply Navier-Stokes equation, you need to convert Navier-Stokes equation directly, that is analytically not, you cannot solve. So what you will do is still a question, whether you can solve or not solve is still a question in scientific. So but for sake of time we can't solve the Navier-Stokes equation directly. So what we do, we actually convert your this Navier-Stokes equation in form of Reynolds average Navier-Stokes equation. This is the high level of mechanics, advanced fluid mechanics. Navier-Stokes, Reynolds average Navier-Stokes equation, and these equation we actually formulate in forms of algebraic equation using these three method, and after that uh, write a code for that and try to solve the equations, try to solve the final equation, and you can definitely get the here value of velocity. So basically we involve the numerical one. So remember please. So these are the basically basic concept behind your CFD, what I was telling previous. But the answer simple, answer is numerical. In CFD you actually solve the numerical equations because these are the numerical method, remember please. CFD uses the numerical experimentations to obtain the flow properties in discrete point. Computer program are used to carry out these experiments. Okay. So now we'll move on the next question. Question number 2. So here the reason of interest for analysis in CFD is known as reason of interest. Let us suppose here I want to find out the velocity in this region. In this region I want to find out the velocity throughout. At each point I want to find out velocity. So this is the reason. So this reason in CFD actually we know by a particular term, and the term is cell, domain, mesh or grid. Which one? Please try to write your answer based on your understanding of week 11 classes. So question number 2. Everyone please try to write the answer. So this actually the week 11 syllabus was from your advanced fluid mechanics. Generally in the undergraduate level, uh, actually this is I think not from your syllabus of undergraduate level. This is the from your, but basic you can understand. Hope in video the sir have cleared all concepts, so you are able to give the answer for this question. Please everyone try to write your answer in the chat box. The reason of interest for the analysis in CFD is known as, whatever you know please try to write. Finally I'll tell you the final answer, but first you try to write your answer please. Okay, Manoj is telling 2B domain. Good. Other student please also try to write. So here is the reason of interest. Basically what I was telling, what is the reason of interest, let me just discuss again. So let us suppose you have some pipe, and pipe like that, not simple pipe, you have the pipe like that. Here is very small area, here is area is high, so area is varying throughout. So actually you want to find out the velocity and this reason, how at the bend your velocity is varying throughout the pipe, how velocity is varying. So this is your reason of interest. So here you want to study the velocity or whatever parameters you want to study. Turbulence parameter also you can study. So this actually we know by domain. So remember please, option question 2, option B will be correct for question number 2. Next question. So here you can just see the detailed solution. The reason of interest for solving a particular fluid flow problem is called domain. The first step in pre-processing is to define geometry of this domain. Okay, the next question. CFD package solve the algebraic equation, whatever I was discussed previously, of the flow using direct method, iterative method, analytical method, trial and error method. Which one correct for question number 3? Please everyone try for question number 3. Everyone please try. Just recall your concepts and try to write your answer please. Whatever you know, just you try to write. There is no whether you will correct or wrong. But here if you will write your answer, then when I'll tell the correct answer, so you will remember for a long time. So that's why I am saying again and again to write your answer in the chat box for the question number 3. Please everyone. So actually when you will write the answer, that the session will be more engaging. So that will be good for me also and you also. So everyone please try to write. Because the discussion should be from both sides. So here we are discussing some previous questions, so discussion should be from both sides, not one-sided. So that will be more beneficial for you if you will write your answer in the chat box. Okay, Amit is telling 3B, Manoj is telling 3D. Okay, trial and error. Amit is telling iterative. Okay, Okay, so no one. So yes, actually in the CFD package we solve the algebraic equation by iterative method. Remember please, option B will be correct for question number 3. So here you can see the detailed solution. The physical phenomena, the physical phenomenon make the algebraic equation complex and non-linear. Hence, an iterative method is used in CFD package to solve these equations. So why we use the iterative? So iterative method. So here you can see the physical phenomena make the algebraic equation complex and non-linear. So here we need to the iterative method for solving such cases. Okay, so we'll move on the next question. Question number 4. Which of these will fall into the post-processing category? Defining of boundary condition, grid generation, flow visualization, and discretization. Which of the following and which of these will fall into the post-processing category? Post-processing we are talking about here. Okay, 4C. Amit is telling C option, flow visualization. Okay. Other student, please also try to write your answer in the chat box. Okay, other student, please, if anyone want to write, you have 1 minute more. So just recall your concept and try to write. If anyone want to write, please write within 1 minute. Okay, let me discuss. So here the question is post processing. So as you know already, the post name is here after the processing or after the run your CFD. That is after the calculation. So what you will do for calculation, we need grid generation, discretization also we need, boundary condition also we need to apply. Only the flow visualization do after the your calculation, that is in the post processing category, flow visualization will come. Yes, Amit is correct. So option C for question number 4, flow visualization. Yes. So detailed solution here, if you want to read, the post processing is the final step in the CFD after pre-processing and solving, and this involve various method of visualization, the flow, as well as getting quantitative information. Quantitative means that is how much, that is the velocity you know already, but how much velocity, whether 2 meter per second, 1 meter per second, how much, so that is the quantitative information. Okay, we'll move on the next question. Question number 5. Which is the input part of CFD problem? Whether post processing, flow visualization, pre-processing, solving. Which is the input part? Here the question is asking about input part of the CFD problem. For question number 5, please everyone try to participate. For question number 5. You have 2-3 minutes, so please within time slot you try to write your answer. Just recall your concept and try to write. Okay, Amit is telling 4C. Okay, no, oh, this is a question number 5, Amit, I'm talking about, not 4. So if you are telling for 5, then okay, 5C. Other student, please also try to write. Okay, okay, 5C. Anyone want to tell? Please, you can write. Okay, so let me just discuss. So here question is about the input part. So remember please, the input part of a CFD problem. So input, the post processing, you have seen already what is the post processing, and flow visualization also the part of the post processing, and solving is the another next step. Here we are talking about the input part, only the remaining is pre-processing. So you will go with the option C. Yes, Amit, option is correct. The for question number 5, option C will be correct, that is pre-processing. Here you can read the detailed solution. The pre-processing part of CFD problem is the first step before starting the process the problem, and this is where the input are specified. Remember please. The next question, question number 6. Which of these model would be the best for flow over submarine? Which of these model would be the best for the flow over submarine? Here one example is given, submarine. So whether 3D Navier-Stokes equation for compressible flow without a turbulence model. Option B, 3D Navier-Stokes equation for compressible flow without a turbulence model. The 3D Navier-Stokes equation for compressible flow with turbulence model. The 3D Navier-Stokes equation for incompressible flow with turbulence model. Here we are talking about submarine, remember please. And submarine, okay, just you try to write your answer, then after I'll discuss. So first you please try to write your answer for question number 6. Very important question. So everyone please just think, just read the question first and think and then try to write your answer in the chat box for question number 7. Oh, question number 6, not 7. So everyone please. Okay, but they is telling 6b, 3D Navier-Stokes equation for incompressible flow without a turbulence model. Okay, 6b. Other student, please think like that and write your answer. Think like Vedya, what he has tell. Option B, you can also write your answer in similar manner. Just try to think and write your answer. Here we are talking about best one. Remember one thing, we are talking here best one. You can solve by A, B, C, D, whatever, but we are talking, the question is talking about best one. Okay, Amit is telling C, okay, 6C. Other student, please also try to write your answer. Manoj is telling C, 6C, okay. Other student want to write? Okay, let me just discuss for question number 6. So here the submarine, you know already the submarine always flow in water. So here you want to model. Model means you want to find out the, that is, let us assume this is your water and submarine is like that. submarine is going like that in this direction. So you want to model here the pressure, the velocity and turbulence. As you know, the submarine will enter in the water, or when move in water, the lot of turbulence. So turbulence, all turbulence means the turbulent kinetic energy or turbulent, the level of turbulence, eddies. So that thing also, that parameter you also want to, you need to also look, because here we are talking about the best. So water, you know already, generally we consider the incompressible fluid. So yes, so you need to involve incompressible, good one. And also the turbulence, because the flow is not, when your submarine will move in water, so your flow will turbulence, definitely not your laminar. So you will go with the turbulence model as well as incompressible flow, and Navier-Stokes equation is compulsory. So here option D will be correct for question number 6. So remember please, how you will remember. So I have discussed little bit. Okay. So here detail solutions also you can see. The option D, the 3D Navier-Stokes equation for incompressible flow with turbulence model. But the detailed solution is the incompressible flow is chosen as the flow of water will mostly be incompressible. The turbulence model is chosen as the turbulence model is chosen as the flow properties will get abrupt change due to high Reynolds number. So you know already. These things I have discussed. Now we'll move on the next question. Question number 7. What would be the major difference between aerodynamic and thermodynamic analysis? What would be the major difference? Aerodynamic and thermodynamic analysis. Temperature, Reynolds number, velocity, domain. The major difference. So everyone please try to write your answer for question number 7. Just think on that and try to write. Okay, Amit is telling 7B. Reynolds number, okay. Other student, please also try to write your answer. Okay, Manoj is also telling 7B. Reynolds number, okay. Okay. Mangal Chand also telling option B, okay. Anyone want to write, or should I? Okay, 1 minute I'll also 1 minute I'll give. So within 1 minute, other student also can write. Okay, let me discuss. So, yes, definitely. So here is Reynolds number. So detailed solution is the Reynolds number. Just read. Yes, the Reynolds number of the flow would be measure change as the density and viscosity of water will be higher than that of air. So you know already. Therefore, because the viscosity of air and water is major different, and therefore, while modeling a hydrodynamic flow, care should be taken whether you are doing with air or water. Next question. Which of these is not a type of flow based on their mathematical behavior? Circular, elliptical, parabolic, hyperbolic. So just think what this question is asking, then after try to write your answer in the chat box. Here also itself a question is not in okay. Manoj is telling D option hyperbolic. Okay. Other student please also try to write your answer. For question number 8, please everyone try to write your answer. Okay. Mangalchan telling D option. Okay. Other student please also try to write your answer. And whatever you are thinking, which option will be correct, you can write. Okay, B. Amit is telling B. So here the question is little bit twist. So if you will think, I have discussed in the previous questions also what are the flow based equations and all. So if you will think, then you can very easily write your answer. Amit is telling 8B. Okay. For this question, I'll give another 1 minute. So please rethink everyone and try to write. Everyone please rethink and try to write your answer. Read the question very carefully and try to write. Okay. So Manoj is having the query. The whether the question is yes, I think. Uh, Not all, but you may, I think 50% you can get. Not all questions, but maybe you can get the 50% very easily. But you have to go with all your assignment, the current year assignment. Okay, let me discuss. So you know already the flow based equation what I was discussed previously. These are, which of these is not a type of flow based on the mathematical behavior. So you know already the flow based equation, you have the partial differential equation. Partial differential equation. So we defined actually your partial differential equation in elliptical, whether it may be the elliptical, whether it may be parabolic, whether it may be the hyperbolic, not circular. So here the question is not, so option A will be correct for question number this 8 question. So here your A option will be correct. Remember please. Now we'll move on the next question. So three type of flow based on mathematical behavior. Three type of flow based on mathematical behavior. Three type of flows. What type of? One may be elliptical, another one parabolic, another one hyperbolic, and these behavior decide the method used to solve the mathematical model of the flow. Whether if your equation is behaving elliptical, so you have to choose the specific type of mathematical model for that. If your equation is behaving parabolic, so you have to select some group of or some selected mathematical models. Mathematical model means here the group of equations, remember please. Next question, question number 9. Which type of flow does Laplace equation belong to? Hyperbolic, parabolic, elliptic, none of the above. So please try to think, and I'll take here 5 minute break. So you anyone want break, you can also take. Otherwise, I'm going to take. Hello? Yes. So Amit is telling 9ABC means 9ABC means you are telling all three or A or B, C. What you are telling? Just please clarify whether you are telling all three or okay, all three you are telling. Okay. So question is here if you have okay, Manoj is telling 9C elliptical elliptic. Okay. So question is here which type of flow, whether parabolic, hyperbolic or elliptic, Laplace equation belong to. So as you know the Laplace equation may be look like for 2D, for velocity 2D I am going to write. So this is a Laplace equation. But how you will identify whether this equation is hyperbolic, parabolic or elliptical? So I have another document. Yes, here you can see 11.1. Hope the PDF is visible, right? New PDF is visible, please. Classification of second order equation. Anyone write yes in the chat box? Whether visible or not? Okay, good. So here the equation is A d square u by dx square plus B d square u by dx dy plus C d square u by dy square plus whatever. There is no meaning because we are only interested with ABC. So if B square minus 4AC will be less than 0 means minus value. Less than 0 it will be elliptical. If B square minus 4AC will be 0 then parabolic. If B square minus 4AC will be greater than 0 then hyperbolic. And this is parabolic. So here in your equation, basically Laplace equation, so equal to 0. Here I want to write 1. Here also I want to write 1. So match x, here is square, yes, x square, x square. So a is equal to 1, dx dy. Here dx dy is no term, so b is equal to 0. C y square, here also y square you have. So C here is 1, meaning b square means 0 square minus 4 1 and c is also 1. So finally is minus 4 which is less than 0 means negative. So your equation will be elliptic. Remember please the Laplace equation is elliptic. Okay. Moving ahead with the new questions. Question number 10. So here option C will be correct for question number 9. Such question you can expect in your mathematical exam like GATE exam also. In GATE exam, I think 2-3 times such type of questions you can see the previous year. Okay, so question number 10. The classification of partial differential equation PDEs, the partial differential equations are governed by their highest order derivative, their least order derivative, the number of term, the constant. The classification of partial differential equations are governed by their higher order derivative, their least order derivative, the number of term, the constant. So please try to write your answer in the chat box for question number 10. Okay, Manoj answer is correct for previous one 9C. Okay, elliptical. So please try to write the answer for question number 10. Okay, you are telling the about the gate questions, right? Okay. So we have one more class, maybe on next Friday on 11. After that, if anyone have any doubt, you can write in video comment or you can also write me. So I'll give my mail ID in the log sheet where I have provided you the link, the YouTube link. Actually, NPTEL team the provided you the link of Excel sheet which having the YouTube link and this file, the assignment files. So in that link I'll discuss. I'll write my mail ID. So if anyone have any doubt, you can write. Okay, Ranjit is telling B option, the least order derivative. Okay. The classification of partial differential equation governed by Ranjit is telling B, that is their least order derivative. Okay, Manoj is telling 10A, the highest, their highest order derivative. Okay, let me just show you the answer. So option A is correct, yes. Their highest order derivative. The highest order derivative of partial differential equation determine its type. Whether it is, that is the type means what we were discussing, the elliptical and all that thing, or maybe the degree and order, that thing also. I think here is question is involved, these things also. Okay, but remember please, the classification of partial differential equation are governed by their highest order derivatives. Highest order derivative means maybe you have one equation like that. You here is not. So like that. So this is the highest order. So we'll actually the classification of partial differential equation. During the classification, you will see this term. The question is talking about. The answer is talking about this. Now the question number 11. The stability in is the property of a partial differential equation, discretized equation, and discretization process or mathematical model. The stability is the property of a partial differential equation, discretized equation, discretization process or mathematical model. Which option will be correct for question number 11? So everyone please try to write answer for question number 11. Anyone please write your answer. Okay, let me show you the answer. So the stability is the property of your discretized equation. The stability is not a property of discretization process. It is the property of the resulting system of discretized equation, and this can be analyzed mathematically for the system of stability does not exist for a partial differential equation or mathematical model. So remember please. Next question, question number 12. The small eddy scale are known as the small eddy scale are known as Taylor scale, Taylor microscale, Kolmogorov microscale, or integral length scale. Which option will be correct for question number 12? So everyone please try to write your answer for question number 12. 12. Okay, Manoj is telling B, the Taylor micro scales. Okay, the small AD scales are known as. Okay, other student please also try to write your answer. After that, I have the another questions NPTEL 2023 hydraulic engineering. So I'll discuss that questions also. Anyone want to write? Twelve A. Okay. Actor scale. Okay. Okay. Let me just show you the answer. So known as the Kolmogorov microscales. Remember, please. The small eddies with dominating viscosity are called Kolmogorov microscale, and it and it is named after the Russian scientist Andrew Kolmogorov, who carried out work on the structure of turbulence in 1940s. So remember, please. Now the next question number your okay, question number 1 we have already seen in the previous year assignments. The your Navier-Stokes equation are the coupled system. Remember, please, coupled system. So we have seen in the previous days. Now the next question is, so here is just you can see the Navier-Stokes equation are called coupled system of equation because all the equations should be solved to get dependent variable, and equation cannot be solved separately to get the unknown. So if the situation like that, known such equation known as the coupled. Okay, here is the okay. The diffusion term are not included in continuity equation, momentum equation, and jet momentum equation or energy equation. Okay. The diffusion term are not included in the answer. You can see here the option C will be correct, the jet moment equation. The diffusion term are not included in the jet moment equation of Navier-Stokes equation. Why? The reason is written. Let me just read. The mass diffusion of the continuity equation are in general not included in the Navier-Stokes equation mass diffusion. This is because most of the fluid flow and thermodynamic process do not include any change in concentration with concentration, which is mass diffusion. So this is the reason diffusion term are not included in your jet momentum equation. Next question 3. Okay, the question 3, the turbulence problems particularly depend on this term of Navier-Stokes equation, which is rate of change term, convective term, diffusion term, and source term. The turbulence problem particularly depend on this term. Which term? You can write your answer. The four term is written A, B, C, D. So please everyone try to write. For question number 3, 1 and 2 we have already solved. 3A, rate of change term. Okay, rate of change. Other student please also try to write. Amit is telling rate of change. Okay, let me discuss. Or let me just show you the answer. So turbulence problem particularly depend on the term of in the Navier-Stokes equation your diffusion term. Remember please. Diffusion term. So turbulence is caused by abrupt change. Turbulence is caused by abrupt change in velocities perpendicular to the flow. Perpendicular to the flow, and this in turn can be given in viscosity term. Diffusion term of the Navier-Stokes equation hold the viscosity term. So without diffusion term we cannot model turbulence. So remember please. Next question. Question number 4. What are two major type of boundary condition? Wall and symmetry, inlet and outlet, and the Dirichlet and Newman, and initial and physical. So please try to write your answer for question number 4. Wall and symmetry, inlet and outlet, Dirichlet and Newman, initial and physical. For question number 4, which option will be correct? B. Inlet and outlet. Ranjit is telling. Okay. The measure here we are talking about measure. Okay. Ranjit is telling B. Other student, please also you can write. For question number 4. Okay. Manoj is telling A. Wall and symmetry. Other student, please. For question number 4. Other student, please also try to write your answer. Okay, let me just discuss the question number 4. So the major two type of boundary conditions. So these are the basic, whether you will apply the wall and symmetry and initial and physical inlet out. The main type here we are talking about. So not actually here the not the we are talking about the name of boundary condition types. So the option will be your Dirichlet and Newman. So remember please, option C will be correct for question number 4. So Dirichlet and Newman boundary condition are the two boundary conditions. They are used to define condition in the physical boundary of a problem. Next question, question number 5. Anyone want to say something? Or no? Okay. Which of these does not come under the partial differential equation? Laplace equation, equation of motion, 1D wave equation, heat equation. Not come under the partial differential equation. So please, very basic question. So please everyone try to write the answer. Very fundamental and basic equation. For question number 5. Okay, Ranjit is telling A, Laplace equation not come under the partial differential equation. Okay. Other student, please also. Based on your understanding, you just try to write answer. Everyone, please try to write your answer. Okay. Manoj is telling B option, equation of motion. Okay. Anyone want to say something? 1 minute you have more, so please within 1 minute you try to write answer. Okay, let me just show you. So yes, definitely the Laplace equation, you have the partial difference equation, you know already, like that what I was discussed previously. This is partial differential equation. Equation of motion, you not, this is not belong to your partial differential equation. Definitely option B will be correct. So here is the equation of motion come under the ordinary differential equation, and Laplace equation, wave equation and heat equation are all partial differential equations. Next question, question number 6. If we are solving K epsilon model, the value of K and epsilon are either specified or estimated at the inlet, are either specified or estimated at the outlet, need not be specified or estimated anywhere, and are not estimated. Which option will be correct for question number 6? Please everyone try to write your answer for question number 6. Everyone please. Okay, Manoj is telling A option are either specified or estimate at the inlet. Okay. Other student, please also try to write your answer.
Anyone, please, you can write your answer.
Okay, let me just discuss. So during solving the cap silent model, you have to specify or estimate at inlet your K and epsilon value. Definitely option A will be correct. The most accurate solution can be achieved only if K and epsilon are specified at the inlet boundary. However, if it is not possible to provide, CFD code can estimate these values using the using a formula. Question number 7. The discretization of the physical domain of interest result in boundaries, discretized equation, discrete cell exponential equation. Discretization of the physical domain of interest result in boundaries, discretized equation, discrete cell or exponential equations. Which option will be correct? Please you try to write your answer in the chat box. For question number 7. Okay, but Ranjit is telling B option 7B, discretized equation. Okay, other student please also try to write your answer. Anyone want to write, please? You have 1 minute, next 1 minute, so you can write your answer. Just think and recall your concepts and try to write your answer in the chat box. Anyone want to write? Okay, let me just show you. The question is here, discretization of the physical domain of interest result in, let me just show you, C option, discrete cell. Means let us suppose You have some physical domain. This is your physical domain. This is discrete cell means you have the you will solve this domain. This domain is only this domain. This domain you will solve using the number of discrete cell. That is, first your equation will solve for this cell, then again for this cell, again for this cell, again for this cell, like that. So like that your cell, connected cell. So move from inlet to outlet. Okay, so explanation we can read. So discretization of the physical domain means dividing the region of interest into discrete element, what I was telling, and this will result in discrete cell on which the rest of solution process depend. Next, question number 8. The equation of discretization is the process of converting open form, closed form, linear or quasi-linear partial differential equation into discretized equation. Which option will be correct for question number 8? Open form, closed form, linear or quasi-linear? So please try to write your answer in the chat box for question number 8. Everyone please try to write your answer in the chat box for question number 8. Okay. So Amit is telling D option, Ranjit is telling C option. Okay, let me just show you. Yes, B option will be correct. That is the closed form. Remember, please. The equation of discretization is the process of converting partial differential equation into the closed form. Remember, please. Closed form of partial differential equation into discretized equation. So here you can read the closed form contain the closed form the continuous partial differential equation are converted into discretized equations and suitable for numerical solution. Analytical solution of these closed form partial differential equations will give continuous equation which can be used to get the flow variable at any desired point in the domain. Okay, so we'll move on the next question. Next question is question number 9. Very easy question. Eddies in turbulent flow result in high diffusion coefficient, less diffusion coefficient, high value of source term and low value of source term. Eddies in turbulent flow result in high diffusion coefficient, less diffusion coefficient, high value of source term and low value of source term. So please, based on your understanding, try to write your answer in the chat box. Everyone, please try to write your answer in the chat box based on your understanding. For question number 9, we have another 3 problems. Okay, 9A. Ranjit is telling 9A. Other student, please also try to write your answer. High diffusion coefficient, Ranjit is telling. Other student, please also try to write your answer in the chat box. Okay, let me just show you the answer. So Manoj is also telling A option. So here A option will be correct. The high diffusion coefficient eddies you will provide. Eddies will provide you the high, remember please, high diffusion coefficient. Because the eddy's motion of turbulent flow, heat, mass and momentum are effectively exchanged. So the value of diffusion coefficient of heat, mass and momentum are high. To close the Rance equation, that is the Reynolds average Navier-Stokes equation, we need incompressible flow model, DNS model, turbulence model or SGS model. Which option will be correct? To close the Rance equation means Reynolds average Navier-Stokes equation. So anyone please write your answer. Anyone? Okay. for question number 10. Yes, you can get the. I think NPTEL team will provide you these things. NPTEL team will provide you because I have uploaded these all the questions and answers and whatever material I taught you in the previous classes or today what I am teaching. These things I have uploaded in a folder and the link of the folder already provided. Okay, okay, just wait. I think link is there. If you are not able to find out, I don't know why. Because here I have already. Okay, let me just share you this link. Here you can find everything. The link of recorded video and all PDFs. Okay, the answer for this question is C. That is a tubeless model. You need tubeless model. Next question. Question number 11. So it is impossible to drive a closed set of Rance equations. So some approximation in the flow model are done and these approximation are called turbulence model and this usually means prescribing the Reynolds stresses and turbulence scalar flux in terms of the mean flow quantities. Next question. Question number 11. The difference between the exact analytical solution of partial differential equation and its numerical solution is as round off error, discretization error, iteration error or the modeling error. Question number 11. So please you can ask this question by the TA of hydraulic engineering. Whatever you have studied or what you have seen the videos of hydraulic engineering on NPTEL, so you can write your answer or write your question actually for these TA. Actually, I am not involved directly with the IIT Kharagpur hydraulic engineering. So I am from IIT Guwahati. So you can write that those TAs. So those TA will clarify. Okay, so let me just show you. Option B means discretization error. What you have discretized, that error you can see only in the analytical solution and your numerical solution. The discretization error is the error arising due to the numerical solution of partial differential equations. It includes the error due to numerical approximation of the governing equation and boundary conditions. So remember please. Next question. Oh, question number 12. The convergence is defined for eliminating method, iterative solver, direct solver, and the Cramer's method. So option A is correct, that is your elimination method. The convergence is a property of the iterative solver used for solving the discretized system of equation. It cannot be defined for direct solver as they do not have repeated step and similar answers. So this is what for today. So thank you. We'll meet again in the next class. That is maybe on next Friday, 11. So thank you all. Now everyone can leave the class. Okay. Everyone can leave.